All right, so we're back for some more examples. And so now we're doing typing speed. So it says the function W gives the number of words per minute, WPM, that a student in a keyboard class can type after T weeks in the course. Now, is it possible for W2 to be negative? All right, so can we type negative numbers of words? No, it's not possible. No, we cannot type negative amounts of words. Okay. So then it says, what are the units on dW over dt? So dW is going to be, the number of words per minute. dt is going to be the number of weeks. So it's going to be words per minute per week, because t is in weeks. And when you divide it out, it's just going to end up being the 1 week. So it's going to be words per minute per week. And so, if we wanted to write it as a whole line and we use that WPM, that's WPM and then per week. So that would be our units. And this is basically at week 2, okay? Now, is it possible for the derivative of this W to be at t equals 2 to be negative? Well, and if maybe on the first week you were at 40 words, and the second week somehow maybe you hurt a finger and you dropped to 30 words. Is that possible? Yeah, because what this is saying is your rate at week 2 is going to be negative. So basically we're saying yes, the number of words typed per minute is decreasing at week 2. Okay, so that's why, because all of a sudden you've gone down and you're slowed down, and so maybe here's week 1. This is gonna let me draw week 1, and then all of a sudden you started going down because you hurt your finger or whatever. So you've started decreasing, and so that derivative at this point, if we do the instantaneous velocity or typing words per minute, that's going to be negative, and so we're gonna have a negative slope. So yes, it's possible for that to be negative. Okay. All right, political membership. So the function M gives the number of members in a political organization T years after its founding. So what are the units on M prime of 10, basically? Okay. So, well, what is the units? Well, M is number of members, T is in years, so it's going to be members per year. And after you divide it, it's just, members per year. So if we write it out as a sentence, it's going to be members per year. Okay. Now, is it possible for that to be negative, for the m prime to be negative, the derivative of m? Well, yeah, it's sure it's possible, because what happens if you're decreasing your membership? So, maybe you've been going along, it's been steady and steady, and then after 10 years, people are like, I don't want to do this anymore. And it starts going down. And say this is, at year 10, that's going to be your tangent line, and so it's going to get negative once you get there. So if this is a straight line, more than likely it's going to be some kind of a curve. It's going to go down like this, and so after 10 years, maybe that's at the 10-year mark, that's the tangent point, and so you have a negative slope. So yes, uh, it how do we want to say yes, it can, if the number of members is again decreasing 10 years after the, is it a club organization was founded. Okay, so it can happen. And so that would be kind of what it is. And in this whole section, we're going to have to start thinking about drawing things, seeing what it could be. And so later on, we're actually going to have to draw graphs of what these things are meaning. All right. Oh, here's one already. So sketch a possible graph of t with input x given that we have t of 3 equals 7, t of 4.4 equals t of 8 equals 0, t prime is 6.2 is equal to 0. So what does that mean? That means the derivative is 0, so we have a slope is equal to 0 at that point. And then the graph has no concavity changes. All right, so let's think about this. We might need top and bottom. Maybe but we only need to have positive because we only have positive numbers here. So I don't know. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we go 1, 2, 3, 4, 5, 6, 7. All right. So T3 equals 7. So 1, 2, 3. That's where we are. Let's go and count these. 1, 2, 3, 4, 5, 6, 7 is here. 3 is here. So we have about a point there. Then we know at T 4.4, so here's 2, 4.4 is going to be 0. And then 5, 6, 7, 8 is going to be 0. And we know the slope at 6.2, so that's 5, 6.2. At this point here, let's change the color so we can actually mark it, know where we're at there. 8, 7, 6.2, that point is going to have a slope of 0. So it's going to have something, like that, or like that, where we have a horizontal thing. Okay, again, can't draw very well, but that's okay. So we have to think about this. So it's up here at 7, and we don't have any concavity changes, so we can't go concave up, then concave down. So what we have to do is we have to have one single kind of graph. And so I think if I'm going to do this, I have to come down here. Then I'm going to have to come back up here. And then I don't know where this point is. But what's going to happen is at this point, that's going to have kind of the change of direction. We're still going to be, in this case, concave up, but we have our slope is equal to 0. Our derivative at 6.2, if we're assuming that's at 6.2, that slope is going to be 0. And so we've gone down through that point. We've hit the t 4.4, got the slope 0, gone back up to the t of 8 equals 0, and we're going up in that direction. So there's no change in concavity. And so I think that would be how I would draw a graph that is similar to this one. Okay. All right, let's stop there and we'll come back.